What is sedimentation? Sedimentation is the process by which particles suspended in a liquid settle out of the suspension under the influence of gravity or centrifugal force. This process is commonly used in various industries, including water treatment, mining, and food production, to separate solids from liquids or to clarify liquids. Process of sedimentation. In this figure, the process of sedimentation can be observed by a small experiment. Take a jar and fill it with garden variety mud, pour some water, shake well and keep it untouched for a few minutes. In a while it can be noticed that the gravel and rocks have settled below, stand above, and so on. Basically, the garden variety mud has formed layers of soil based on varied. Similarly, looking at a cliff, several layers on the surface of the cliff can be observed. These layers are caused by sedimentation. Over a long period of time, the grains of sand and mud build up, forming the layers. Logically, the quicker the bones are buried, the chances of survival are more than if it is protected from scavenging animals, and less damaged by weather. The sea, rivers, and lakes are the best depositors of sand and mud. Dinosaur fossils were found to be nearer to the sea, lakes, or rivers. A landslide, where mud and rock fall down a mountain of a hill, can also lead to a type of sedimentation. Types of sedimentation. There are 4 types of sedimentation. 1. Discrete or free settling. Occurs when particles settle independently without interacting with each other. Particles retain their size and shape during the settling process. Common in systems with low particle concentrations where particles are far apart. Example, settling of sand particles in water. 2. Flocculent or flocculating settling. Occurs when particles aggregate or flocculate to form larger clumps known as flocks, which then settle as a unit. Particles interact and stick together due to chemical or physical bonding. Common in water and wastewater treatment processes where chemicals are added to promote flocculation. Example, settling of suspended organic matter in wastewater treatment after the addition of a coagulant. 3. Hindered or zone settling. Occurs when the concentration of particles is high, causing them to settle as a mass rather than individually. Particles form a sedimentation front or interface that moves downward as settling progresses. The rate of settling is reduced due to the interaction between particles and the hindered motion of water. Example, settling in thickening tanks in mining operations, where the slurry has a high solids concentration. 4. Compression settling. Happens when particles settle and compact at the bottom due to the weight of the overlying particles. Common in situations where a dense sludge forms at the bottom of the tank. Further settling and compaction occur under the pressure of the sediment above. Example, settling of sludge in the bottom of a clarifier in sewage treatment plants. Each type of sedimentation is influenced by factors such as particle size, shape, concentration, and the properties of the liquid medium. Understanding these types helps in designing and optimizing processes for efficient solid-liquid separation.